techdaily.ai, your source for technical information. This podcast is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyper-converged in VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com. Welcome back to the deep dive. We're here again, taking the info you send us, digging in, and figuring out what really matters. Today, we're tackling something super common, maybe something you already have or are thinking about, network-attached storage. NAS.
Yeah, NAS. So at its heart, it's basically storage that sits on your network, right? It talks using standard network stuff, IP addresses, and it's really built for sharing files between, different people or different devices. It runs its own little operating system, too.
It sounds pretty simple, yeah, just a box for your files. But when you start digging into the material you folks shared, you realize there's actually quite a bit under the hood. Stuff like picking the right hard drives and, well, the surprisingly tricky part of keeping all that data safe.
Definitely more to it than meets the eye sometimes.
So our mission today is to cut through that, pull out the really useful nuggets from everything we've looked at, the practical stuff, what's possible, and get you up to speed quickly but properly.
Sounds good. So why do people actually use NAS? Well, its main gig is handling what we call unstructured data. Think documents, photos, videos, spreadsheets, maybe those massive OBS recordings streamers generate, or video editing files, just general long-term storage, really.
It's kind of the go-to for that sort of shared stuff. And the sources definitely highlight a few key reasons why.
Oh, yeah. For a lot of people, especially maybe home users or small businesses, cost is a huge one. If you compare it to something like a big enterprise storage area network, a SAN, well, a NAS is usually way more affordable.
Right, makes sense. A lot of storage space without breaking the bank.
And, for the simpler units, they're pretty easy to run. You don't always need a dedicated IT person just for the NAS. That makes them really popular. Plus, they give you that 24/7 access, often remotely, too, which is just essential now.
Totally essential, yeah. Especially with remote work and collaboration.
Exactly. And unlike, say, a USB drive plugged into one computer that's direct attached storage, or DAS, a NAS is designed for lots of people hitting the files at the same time. They speak standard network languages like NFS for Linux Mac, SMB for Windows, so they just slot into most networks easily.
And they usually have built-in ways to handle drive failures, like RAID.
Yep. RAID is a big feature. It basically links multiple physical drives together, so your computer sees them as one bigger storage pool. And the important part is redundancy. If one hard drive kicks the bucket.
Which they sometimes do.
Which they do. You don't lose all your data because it's spread out or copied across the other drives.
Okay, but I know we'll circle back to this. RAID protects you if a drive dies.
Yeah.
It's not really a backup if you, accidentally delete a huge folder or get hit by ransomware, right?
That's a super important distinction. Absolutely crucial. RAID is for availability, keeping things running if hardware fails. It's not a backup. But beyond RAID, many NAS boxes do offer other useful things, like snapshots, think point-in-time copies, or data deduplication to save space, and often tools to automate backups somewhere else, like to tape or the cloud, or even just another NAS.
So if you ever found yourself juggling external hard drives, or staring at that horrible disk full warning, or trying to email massive files, or just wishing you had one place for all your digital stuff, work files, family videos, everything, then yeah, a NAS is probably something you've looked at. It really solves that core problem of centralizing and sharing data. Okay, let's peek inside the box. What actually holds the data? The hard drives. And wow, judging by the discussions you shared, picking the right drives is a huge deal for people.
Oh, absolutely. It's a constant topic. There's a lot of debate. Generally, people lean towards drives that are specifically marketed for NAS use, things like the WD Red series, Seagate's Iron Wolf, maybe Toshiba's MG series.
But why? What makes a NAS drive different from just a regular desktop drive?
The main thing is usually the firmware inside the drive. It's tuned for being on 24/7, often in close quarters with other vibrating drives, so they tend to have better vibration tolerance, and they're often designed to run a bit cooler and quieter than, say, a high-performance desktop drive.
That quiet part. Definitely important if the NAS is sitting in your living room, not some server closet. The community feedback you sent over on this is fascinating.
It really is. People are laser focused on reliability, obviously, but also cost per terabyte. That's the big metric. And while WD and Seagate are the big names, people are always hunting for that value sweet spot. Looks like new drives are often in that, say, $18 to $22 per terabyte range if you buy from decent places.
But then you see all these strategies to push that cost down, right?
Yeah. Oh, yeah. Like looking at recertified drives, they can be way cheaper, sometimes under $10 a terabyte. But the catch is usually a much shorter warranty. So you're balancing that upfront saving against, well, the risk. And you got to be careful where you buy them from. Some online sellers are a bit sketchy.
And here's where it gets really interesting, I thought. The point that enterprise drives like Seagate Exos or WD Ultrastar are often mechanically almost identical to the NAS drives, especially the big ones.
Yes. Often the same basic hardware platform, and they can be noticeably cheaper sometimes. The trade-off, they're generally louder and often faster, tuned for demanding server workloads. So you might save money, but you might end up with a noisier box. It's a trade-off. Noise versus cost, and maybe slightly different performance.
And even the proper NAS drives aren't exactly silent, are they? Especially the really big capacity ones. Plus, the NAS case itself can sometimes amplify the humming or clicking.
That's true. If you want total silence, you're pretty much looking at using large solid-state drives, SSDs. But the cost per terabyte there is still way higher than spinning disks.
Which leads us to the shucking phenomenon.
Yes, shucking. Basically, buying a cheaper external USB drive, like a WD Elements or something, cracking open the plastic case, and pulling the hard drive out to put inside your NAS.
Because sometimes those externals have the same drives inside.
Exactly. The theory is, especially for higher capacities, the manufacturer might be using the same underlying drives, maybe white label versions of their Red or Iron Wolf drives, but selling the whole external package cheaper to consumers. It's a bit of a gamble. You don't always know exactly what you'll get, but people report getting great deals this way.
So choosing a drive isn't just about specs. It's like this mix of budget, how much noise you can stand, trust in the brand, and maybe even a bit of warranty-voiding DIY.
Pretty much covers it. And just quickly, back on RAID, another common thing people ask about is standard RAID levels, like RAID 5 versus something like Synology's hybrid RAID or SHR. Standard RAID 5 usually needs at least 3 drives to start. SHR is popular because it's, well, more flexible. You can often start with just 2 drives mirrored and then add more drives later, even if they're different sizes. SHR manages the complexity underneath to give you usable space and protection.
That flexibility sounds like a big win if you're building up your storage over time.
It definitely is for home users or small businesses, but, and I know I sound like a broken record, I have to say it again, RAID, SHR, whatever you use, it protects against a drive failing. It is not a backup for your actual files against deletion, corruption, or ransomware. If that data matters, you absolutely need a separate backup strategy, period.
Okay, let's switch gears a bit. NAS is great for lots of things, but it's not perfect, right? Where does it start to hit its limits?
Yeah, the sources definitely point out performance bottlenecks. If you have lots of users hitting the NAS hard at the same time, or if you're doing really intensive stuff like, say, editing high-res video directly off the NAS share, things can slow down noticeably.
So fine for Word docs and spreadsheets maybe, but trying to edit multiple 4K video streams simultaneously might be pushing it.
Could be, yeah, especially over a standard gigabit network. And scaling up traditional NAS can get tricky and expensive too. Just adding more and more individual NAS boxes or trying to massively expand one unit can become a management nightmare, and you start losing that initial cost advantage.
The initial simplicity kind of fades away when you get really big.
And remember, NAS is built for files. That unstructured data we talked about, it's generally not the best choice for things that need super high transaction rates and really low latency, like busy databases. For that kind of workload, you're usually looking at a SAN again, or maybe even DAS for specific servers.
Right. Trying to run a demanding SQL database directly off a typical file-based NAS share is probably asking for trouble.
Probably. And all that NAS traffic goes over your regular network, your LAN. If your network backbone isn't up to snuff, maybe you're still on 1 gigabit Ethernet instead of 10 gig or faster. A busy NAS can actually slow down everything else on the network. And while the basic setup might be easy, managing advanced features, replication, or multiple units can definitely still require some real IT know-how.
One of the biggest challenges that came up repeatedly was data protection. Specifically, how do you reliably back up these huge, ever-growing piles of data, especially when you only have a limited time window overnight to do it?
That's a huge issue. The traditional ways, like using the NDMP protocol that's often built into NAS devices, well, they have drawbacks. Setting up backups to run in parallel to speed things up can be fiddly and manual. The NAS itself might limit how many streams you can run, and you often still need to do periodic full backups of everything, which can take ages and eat up enormous amounts of backup space.
Okay, so we've got the challenges: scaling performance, complexity, and maybe most critically, that data protection headache, which naturally leads us to the modern solutions designed to fix these things.
Right. And this often brings us into the realm of software-defined storage, or SDS.
SDS. Okay, break that down. What is it in plain English?
Think of it like separating the storage brain, the management software, the features like snapshots or replication, the control plane from the actual physical hardware that holds the data. SDS software typically runs on standard, off-the-shelf servers. You provide the drives and the server hardware.
So it's abstracting the control, not the storage itself.
Exactly. The big benefits are flexibility. You're not locked into one vendor's hardware and scalability. You can often just add more standard servers to grow capacity and performance, which is called scaling out. And potentially it can be more cost-effective than buying big proprietary storage systems.
So FDS isn't like a direct competitor to NAS or SAN. It's more of an architectural thing.
Correct. It's an approach. You could absolutely build a NAS system using SDS principles underneath, or use an SDS platform to manage various storage types, including NAS shares.
Got it. Okay, so looking at specific tools for protecting NAS data, the material mentioned solutions like Dell's PowerProtect Data Manager. That sounded quite different.
Yeah, that one's interesting because it's pitched as a software-only way to protect NAS data, and crucially, it's designed to get away from those limitations of NDMP we talked about.
Moving past NDMP, how does it do that?
Well, the goal seems to be overcoming those bottlenecks. It's designed to work with lots of different NAS vendors, not just Dell's own stuff, but also generic network shares using NFS or CIFS.
Okay, vendor agnostic. But how does it handle the sheer volume of data in those tight backup windows?
It uses this approach they call dynamic NAS protection. Under the hood, there's technology called FSA-FBB, which involves crawling the file system and then backing it up. It runs what's called a NAS protection engine, usually as a virtual machine. But the really clever part seems to be this intelligent share slicer.
Intelligent share slicer.
Yeah.
That sounds like it tackles the parallel stream problem NDMP has.
Precisely. Instead of you manually trying to figure out how to split up a huge share for backup or being limited by the NAS itself, this software analyzes the share and automatically divides it into logical slices. Then it backs up all those slices at the same time in parallel, and it can dynamically adjust how many streams it uses based on the workload. This can massively speed things up, especially if you have tons of small files or complex directory structures.
That actually sounds like a really smart way to shrink that backup window.
It definitely helps. Another big feature is forever incremental backups. After the first full backup, it supposedly only ever needs to back up the changes. No more of those painful, time-consuming, periodic full backups. That saves a ton of time in backup storage. It also gives you a central dashboard for managing everything, lets you search the backups, and do file-level recovery, pulling back just specific files or folders if needed, either to the original NAS or somewhere else.
And the notes mentioned newer versions handle things like skipping files with access errors without stopping the whole backup and supporting non-English file names better.
Yeah, small things, but they matter in the real world. So the basic workflow is it scans the share, intelligently slices it up, backs up the slices in parallel using one or more protection engines, and indexes everything. Restoring is just picking what you want from the catalog. The performance tests mentioned show this slicing really helps throughput, but you still need good network bandwidth. They recommend 10 gigabit Ethernet per protection engine, ideally.
Okay, and another solution mentioned was QSAN Xmirror. That sounded more like a disaster recovery thing.
Yeah, different focus. While the Dell tool is really about efficient backup, Xmirror is more about replication for business continuity. It's designed to sync your data between different locations, could be across the office or across the globe. It mentions supporting up to 8 locations. It keeps the data, the permissions, the folder structure all summed up in near real time.
So less about historical backups, more about having a live, ready-to-go copy somewhere else.
Exactly. So if your main site goes down, you can fail over to the replica site much more quickly. It also does versioning keeping. I think it said up to 64 versions of each file, which is useful for rolling back changes or recovering from ransomware too. It seems really geared towards scenarios like having remote offices constantly sync their data back to headquarters or maintaining a dedicated DR site.
It really shows how specialized software can layer on top of that basic NAS box to solve these bigger, more complex problems of protecting data and recovering quickly in a way that scales better.
Yeah, and putting NAS in the bigger storage picture helps too.
Right. We mentioned SAN and DAS briefly. How does NAS compare to object storage? That comes up a lot now.
Object storage is fundamentally different. NAS, as we said, uses a file system, hierarchy folders within folders within folders, drive letters, mount points the way we normally interact with files. Object storage, it's a flat space. Data is stored as objects, each with a unique ID, kind of like a coat check ticket, along with metadata describing it. You typically access it using web-based APIs, like Amazon's S3 API is the most common one.
So no browsing through folders in the same way.
Not natively, no. Object storage is built for massive scale, think petabytes, exabytes, and often designed for geographic distribution. It's fantastic for huge pools of unstructured data, like data lakes for analytics, media archives, backups. It offers really high throughput for reading large objects, but it's generally not great for workloads that need very low latency responses or involve lots of small, random updates to existing files, like a busy database.
So NAS is great for that interactive, user-driven file sharing, while object storage shines for these huge, more static archives or cloud-native applications designed to talk its language.
That's a good way to put it. There are gateways that can make object storage look like a file share to applications, but for things really built for object storage, talking directly via the API is usually best. Some vendors, like Scality was mentioned, actually offer platforms that can serve up both file, NAS, and object access from the same pool of storage, which is interesting.
And just to quickly tie back SDS, that software-defined storage idea, is that underlying architectural approach that gives you flexibility and scale, and you could run NAS services on top of an SDS platform.
Exactly. Understanding these different tiers helps you see why you might choose NAS for your shared documents, maybe object storage for long-term video archives, and perhaps a SAN for your really high-performance databases. Each has its strengths.
So we started with that seemingly simple network-attached storage box, just shared files, right? And we've gone through the weeds of picking hard drives, the surprising community tactics there, looked at where NAS hits its limits in performance and scale, and then explored these really powerful modern software tools that are tackling the big challenges of backup and disaster recovery.
Yeah, I think what really comes through is that while NAS is super accessible and cost-effective for a lot of common uses, once your data starts getting really big or really valuable, you have to think beyond just the basic features built into the box. The fact that there are these sophisticated, often vendor-agnostic tools specifically for NAS protection really highlights how important and how challenging that problem has become.
Which really leaves a final thought for you, the listener. Thinking about how much digital stuff we all accumulate, work, personal photos, videos, projects, and knowing the risks are real, hardware failure, accidents, ransomware, how does the sheer amount and the actual value of the data you're trusting to your NAS change the calculation? Is investing in a dedicated, smarter data protection solution worth it compared to just relying on the built-in backups? Does the potential cost of losing that data make the investment seem different? Something to think about. TechDaily.ai, your source for technical information. This podcast is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyperconverged and VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.